Hi student, in this video lecture we will talk about one of the interesting topic that is about the action mode of action of enzyme. Now the action of enzyme, that enzyme is able to convert a substrate into the product. Now this action of the enzyme, it was explained by two hypotheses. The one is lock and key model, while the second one, that is induced fit model. Now in this lecture we will mainly discuss the lock and key model in detail. So this model mainly relates the substrate and enzyme as lock and key. As we know that the specific key is able to open a specific lock. So in this way, the enzyme is able to convert a specific substrate into the product. So you can easily see that this model is actually, you can see here, this is an enzyme. Now enzyme have a specific site that is called as active site. Now the active site, that is mainly the functional part of the enzyme, while the remaining part of the enzyme, it will make the framework of an enzyme. Now this active site has a specific shape. Now according to the shape of this active site, a specific substrate is able to pax with the enzyme and convert into the product. Now during this state, a specific substrate, it will come and combine with the active site of the enzyme. So you should have to remember this according to the lock and key models. So that mainly the shape of the active site, it is complementary to the shape of the substrate, and this way the interaction that is possible between the substrate and the enzyme. Now when this substrate is, it is able to fix with the active side of the enzyme. Now this substrate, it is converted into the intermediate state that is called as enzyme substrate complex. So it is mainly the intermediate step during the conversion of the substrate into the product. Now after this state, it is mainly unstable state which is converted into the next step. So and the final state, we will get the enzyme, and mainly the substrate, it is finally converted into the products. So mainly the lock and key model, it is mainly related to that the active side of the enzyme, it is rigid, on only the substrate that have a shape that is contributed to the active side of the enzyme, it is converted into the product. And this model is mainly relates that the enzyme act as a lock, while the substrate, it is act as a key. So you should have to remember that in the lock and key model, the rule of the lock, it is provided by enzyme, while the key, that is provided by the substrate. Now, after understanding the concept of the lock and key model, so let we discuss the theory of the lock and key model. Now, the lock and key model, it is mainly proposed by a Emil Fischer in 1894. So this is about the concept that is proposed by this scientist, and that and its date of presentation. Now, what is the statement of the lock and key model is? Now, this model mainly explains that the shape of the active site of an enzyme is complementary to the shape of its substrate. It means that the shape of the substrate, it is similar to the active site of an enzyme. So only this substrate, it is converted into the product. Now the second one, that is as one specific key can often only a specific lock. So this above statement, so this is actually example are related with the lock and key, as a specific key is able to open only a specific lock. So the enzyme and substrate act in this manner. So similarly, one specific enzyme transform only one substrate. So mainly the overall concept of this statement is that a specific substrate that have a shape similar to the active site of an enzyme is transformed into the product. Now you should have to remember that this model is mainly applicable to the non-regulatory enzyme. Now what is non-regulatory enzyme? So non-regulatory enzyme, actually it is also known as constitutive enzyme. Now what is non-regulatory enzyme? Actually these are specific type of the enzyme that perform they had a specific level or a constant level of activity, mean it perform a specific type of the function. Now this activity, it is not affected by physiological condition or the presence of any other biomolecule. No, instead of these physiological condition or presence of other biomolecule. So this kind of situation cannot affect the activity of this enzyme, mean this non-regulatory enzyme perform a specific function. So we will take example that you will understand then what the non-regulatory enzyme is. Now here are some of the example of non-regulatory enzyme, that is protease, lipase, amylase and nuclease. As you can see here, the non-regulatory enzyme is actually the enzyme that have a specific activity or which act only on a specific substrate. As you can see here in case of the protease, so this is normally a non-regulatory enzyme which act only on the protein, while the lipase, it is also a non-regulatory enzyme. It acts only on specific substrate, that is lipid. Amylase, it is actually act on a specific substrate, that is carbohydrate, while nuclease act on a specific substrate, that is nucleic acid. This is the example of the non-regulatory enzyme. Now what is the concept? It is actually the lock and key model. It is applicable for a law non-regulatory enzyme. Now what is the importance, overall importance of the lock and key model? So the first importance, that is, it is the first model to explain the mechanism of enzyme substrate interaction. So this model, for the first time, it explained that how the enzyme and substrate interact with each other. Now to show how what type of the interaction that is found between the enzyme and substrate and its mechanism. So for the first time, this model, lock and key model, explained the interaction between the enzyme and substrate. Now, the second importance of the lock and key model, that is, it explains how the substrate fit into the active site of enzyme like a key into a lock, allowing for a catalytic reaction to occur. It means that only the substrate it's fixed into the active site of the substrate that have a similar shape. Now, as a key is fit into the lock. Now, during this process, when the substrate it is fixed with the active side of the enzyme, during this process the old bonding is break and new bond is formed, and finally the catalytic reaction it is occur and the substrate is finally converted into the product. So this process mainly it is explained by the lock and key model, how the substrate fit into the active side of the importance. So this is the second importance of the lock and key models. Now the third importance, that it explains the stereospecificity of enzyme catalysis. So first of all, what is stereospecificity of enzyme catalysis? Actually, the stereospecificity is actually the ability of enzyme to accept or to recognize a specific optic isomer. Optic isomer, we have the D isomer and L isomer. So which can rotate the plane polarized light into the right side. This is called as D isomer. When the light it is when the plane polarized light it is shifted by toward the left side, it is called as L isomer. Now a specific enzyme is able to only convert a specific substrate or isomer into the product. So you can easily understand by the taking example that we have a specific enzyme, that is D amino acid. Now you can see here it is called D amino acid because on the right side the carboxylic acid group is present, so that's why it is called as D amino acid. D mean dextro, dextro mean toward the right. Now a specific enzyme that is called as D amino acid oxidase. Now this D amino acid oxidate it is only convert this D amino acid into the product, that is keto acid and ammonia. Now if I change this amino acid, less of the this D amino acid, I place the L amino acid. Now the D amino acid it is unable to convert the L amino acid into the product. So this property of the enzyme it is called stereospecificity of the enzyme. Now this process is mainly explained by the lock and key model that was proposed by the Fisher. Now, finally, what is the shortcoming or drawbacks or limitation of the lock and key model is? So here are some of the important limitation or drawback or shortcoming of the lock and key model. The first one, that is it does not account for the flexibility of enzyme. So mainly this lock and key model, it is said that the active site of the enzyme, it is rigid, it is not flexible. It means that in only a specific substrate it will attach with a specific enzyme or active site of the enzyme. So in the active site, the substrate, it is unable to change the shape of the enzyme. So this is the first drawback of the lock and key model. Second one, that is enzyme are specific, mean only a specific enzyme it is able to transform a specific substrate into the product. So this is the second limitation of the lock and key model. The third implication, that is third limitation, that is it is applicable for a small number of enzymes. As this model we have discussed, we will discuss a little bit about it. The lock and key model, it is mainly applicable for the non-regulatory enzyme. So here you can see here that it is mainly applicable for a small number of enzyme, that is non-regulatory enzyme. For the regulatory enzyme, the lock and key model, it is not applicable. Now, the last important, that is it does not explain the stability of transition state. Now, what is transition state? Transition state is, it is actually a intermediate state in the induced fit model. During this stage, the old bonding is, it is broken down, a new bond is formed, and finally the substrate after this state, it is converted into the product. It is actually for a short period of time and highly unstable state of the complex. Now during this state, after this state, the substrate, it is converted into the product. Now this model does not explain the stability of this transition state. Now here these are all about the lock and key model, its importance, application, statement or postulate of the lock and key model, and its applicability. So this is all about the lock and key model. If you have any question regarding to the lock and key model and your mind, you can ask in the comment section. Thank you so much for watching.